Good afternoon, everyone. My name is Lochin Kit, or you can call me Tommy. Today, I'm going to present my FYP project, and my project title is the implementation of network CRAN machine using ESP32 and ESP32-CAM. In today's agenda, I will first introduce my motivation of this project and some background, and then my project objective, the design, and the result with a demo video. So first, the motivation. Why I do this project? The first reason is because online crime machine is very popular nowadays, especially the days of quarantine when most of the people staying at home and need some entertainment. So what is online crane game? I believe that all of you have seen or even played the arcade crane game in some game center, shopping mall, or just in the corridor next to the retail store or restaurant. So now with the advanced technology in the embedded system, with wireless communication and web application, the whole crane game can go into website or mobile app to access and control the crane machine. After we win the game, the prize will be shipped by the operator to your house, which is really convenient. So this is the new type business that apply the cutting edge technology. So I would like to implement it with a low cost and low power way using what I have learned in these years. Another reason is that when I do literal study about online crane machine, very few paper and resources came out. So I would like to do a technical project about this interesting topic, which has been simply discussed. So here comes to the background. Currently, we already have some operators of online crane machine service. One of the famous app called Toriba, developed by Cyberstep company from Japan. The main components of the online crane machine consist of a web server, a crane machine itself, the webcams, and also the Wi-Fi router to connect the internet. One of the important technology applied here is video streaming. Unlike the old type of downloading mode, which download the whole video before it play back, the streaming mode used nowadays allowed live video playback while the video download is still in progress. It saves the time for downloading the whole video and allowed real-time live video streaming. HTTP, Hypertext Transfer Protocol, is the web standard of network communication protocol that's used in this project. HTTP is an application layer protocol used in transmission of hypermedia information, which is widely used in www. HTTP is a request-response protocol that the client opens the link and sends a request to the web server with a URI or a path. The web server will respond correspondingly. This protocol enables web developer to construct interaction among different internet devices, transmitting resources by applying HTTP method of GET, PUT, POST, or others. The project objective. The main idea of this project is transform a traditional arcade game like the crane game into an e-commerce like the network crane machine using low cost, low power IoT microcontrollers. In this project, we expect that a proposed prototype of a low cost online crane machine with power saving feature will be configured. This project will show the potential of remote administration of machine using cutting-edge IoT microcontroller, which also can be used in different areas other than online crane machine. For example, the manufacturing process. This project will also show the power of ESP32 and ESP32-CAM, which can be also used in different kind of IoT application. Let's go to the system design. The overall system can break it into 4 parts: the web server, the cloud control system, the camera system, and the price detector. The web server contains the web page with the user control interface, handle the wireless communication between the player and the CRAN machine. The cloud control system is to send the control signal to the CRAN machine motherboard to control the claw. The camera system helps to access and control the 3 ESP32-CAM modules, which is the webcam modules. The price detector helps to determine whether there is a price dropping and declare when user win the prize. The main components used here is the ESP32 family, developed by Espressif. I'm using the ESP32 Development Kit C V1 and the ESP32-CAM, an extension version developed by AI Thinker company. The ESP32 Development Kit is responsible to host the web server and work as part of the cloud control system. The ESP32-CAM is a webcam module responsible to configure the camera system. The reason I choose them is because both of them have the Wi-Fi module and dual core in good performance, and also because they are low cost and low power consumption with the ability of sleeping mode, which can turn it into a ultra low power consumption mode during the inactive period. Also, the low cell that's used in price detector. The mechanism is that when a pressure applied on this low cell, it will vary its resistance inside, which also can transfer it into an electrical signal. But the variation is really weak, so we need to use an amplifier, the HX711, to amplify the signal. The first component, the web server, contains the user interface and user functions. It has 2 main tasks. First, to load the video streaming into the website. And secondly, listen to player's button input to execute the claw operation to the CRAN machine motherboard. So here is the user interface of the web page. The upper part is the video streaming window. The lower part is the control panel with the camera switch and also the claw control buttons and the enable buttons. The web server simply uses HTTP GET function to communicate. Just determine the header sent to the ESP32 from user input and execute the action, such as when the user press the claw forward control button, ESP32 will receive a forward header and then output a low to the forward pin on the CRAN machine motherboard and make the claw moving forward. While the button is released, a stop header will send an output high back to the forward pin to stop the claw moving. The claw control system is to send the control signal to the CRAN machine motherboard to control the claw, and the command consists of enable button from the first phase to trigger the con acceptor, and claw control command determined by the control button pressing. So here shows how the hardware interface between ESP32 development kits and the CRAN machine being connected. The camera system mainly provides the video streaming. There are 3 ESP32-CAM modules responsible to 3 different angles of view: the front view, side view, and the top view. When no one accesses the machine, those ESP32-CAM will go into a deep sleep mode, which is an ultra power saving mode. It will turn off most of this function and wait for the wake up event triggered by the ESP32 development kit, when there is a player enter and start streaming. Here illustrate how the camera system works in a better manner. When the player click the camera switch, for example, the side view, as what I highlighted here, the video port will be switched to the unique IP address of the side view ESP32-CAM to get the video information and put it back into the streaming window. To facilitate better attachment of the ESP32-CAM modules, I have decided 3D printed camera attachment for them to hold the camera in a better way. The design starts from scratch with measurement, and then draw the 3D model, and then assemble it together to form the attachment, just showing on the right-hand side. The camera are attached on the crane machine like this way. As shown in the figure on the right-hand side, the cameras of front wheel and side wheel are attached on the crane machine with an adjustable arm. And the figure on the right-hand side shows the top wheel cam is attached right next to the claw. The final component, the price detector, which is built using low cell with HX711 amplifier, to determine whether the player get a price and inform the operator and the player by an LED light. To save the power, I programmed the low cell detection cycle into every 3 seconds, so the low cell won't be active all the time to save the power. Here shows the low cell hardware connection with a HX711 amplifier in the middle. When the price drops and hits the low cell, the LED will light up like what you have seen right here on the left-hand side. So here comes to the most interesting part, the result with a demo video. As what you can see, the prototype is configured as expected, with acceptable smooth video streaming and in appearance delay. To minimize the latency, I have traded off the resolution from 1600 x 1200 to 800 x 600 to have more fluent streaming. The cost of this design is pretty low, around 200 HKD dollar. For the components excluding the crane machine, only takes like 2 to 3% price compared to the crane machine price. And the total power consumption of all components is less than 3 watts in active mode and just around 0.5 watts in sleep mode, which is very impressive. So to conclude, this project shows a successful implementation of a low-cost, low-power online crane machine prototype. It demonstrates the potential of developing smart business using cutting-edge technology like the IoT microcontroller used in this project. In future tasks, this prototype can be upgraded with multiple options of access to different crane machines to make it more commercialized, like thousands of crane machines connected. And better design in user interface and user experience can make it more entertaining. And upgrade with a better network security to provide a higher quality of service. So that's the end of my presentation. Thank you for your listening.